Okay, welcome to the basement. We're gonna start working on this amazing box for the moment. It's blue with a C. It is a Cobalt Qube. Just picked this up on its own, sight unseen. Well, I saw a picture of it. Don't know if it works. But yeah, we got Cobalt Qube. So this is a Qube2 because I believe the original Qube ones didn't say anything right here. Lead strip. Let's take a look at the back. It's quite a heavy, compact little box. All right. Get some zoomies. Cobalt, we got a nasty little fan. We got a lock. We got our all important information here. We got our 16x2 LCD, power, minuscule little reset, selections, select and enter, serial port, 2 Ethernet, a dastardly 3-pin DIN power supply, which we're going to deal with him. I do not have a power supply cable. PCI slot for an expansion. So there was 2 models of this boy. We have the Qube and we have the rack. The Qube, as far as I know, on the Qube2, it came in a single configuration. But the rack came in the base model and the plus. And I want to say the base rack 2 had a single Ethernet. The plus, I think, also had a second Ethernet and a SCSI. I'm looking into all this. So we have some work to do. 1, we need to replace this DIN power supply. We're going to replace the fan. We're going to upgrade the RAM, replace the drive with SATA. If it has a drive in here, it's probably got a honking big 3.5, and it feels like it. It weighs a lot. I also want to power the LCD. I have thoughts about that. So ideally, I want to tie a 555 timer to power the display's backlight. There's no backlight, and it's such a pain in the ass to try and read these if you don't power the backlight. But I don't want it on all the time. So a 555 timer with, like, if I can wire in any button click, we'll lock it on for 15 seconds. That would be great. That's the least important thing I'm going to deal with. Let's get this apart and see what is going on. I expect it's going to be very compact. I expect someone has been in here before me based on, there's 2 locking tabs you can't see on the base gray part, and one of those has been broken. So somebody has been in here, which I would assume for a device from 1998, finding one that hasn't been messed with is probably rare. All right, we got to get up and over the DB9 connector. Come on. We almost had it. All right, we got some dust and some fingerprints on the inside. What's interesting is the Cobalt button, it's molded as an actual button, like we could pop the raised disc out. Probably put an LED in there too. Let's get this out of the way. All right, let's get this cage off. All right. If it does have a drive in here, we want to get that imaged. Do we have any screws in the side or the front? No. All right. But we do have the LED strip stuck on. Okay. There we go. This is well shielded. I wonder if some of that is from the FCC certifications. All right, the big reveal. We do have a honkin' big hard drive. So this card here, sitting in the PCI slot, is actually the processor, which we will pull out. So this has a 250 megahertz MIPS 5231, I believe. We'll see when we get it pulled out. We can remove the lead strip, good. All right, let's get this drive out. Let's not do that so the drive falls in. Change my mind. This is very cramped. All right. What do we got? Quantum Fireball. I presume, well, we have some serial numbers. What does it say? Hmm, 10 gig, so basically a 9 gig drive, I think. Quantum Fireball EL. I'm guessing that this is a 9 gig drive. All right, let's get the rest of this apart. We've got a single stick of RAM. Somebody's definitely been in here. This thing has been threaded, so I really hope I really hope we can get this out. I think we're good. There we go. Let's see if we can replace that. All right, let's get all right, so we have a ribbon cable tying the backboard directly to this board. All right, let's take a look at that. So we have Galileo, which I think is the support chip. This is our Quantum Effect Designs RM5231E, 250 megahertz. This is our 64-bit MIPS chip. Let's see if we can get a better shot. There is our Quantum Effects MIPS processor. There's our support chip. Might be our ROM chip. It's hard to make out. We've got a RAM stick. My guess is it's a 32 or 64 meg RAM stick. I would love to put these through the EEPROM reader, but I don't have a PLCC reader. The other chip is a ST16C650AC. I wonder if that's our serial port, which would be a bit weird being all the way up here, a 16C650. I don't know. But I'm guessing this is our ROM. I do not know what you are. Q something logic. QL8X12B. Quick Logic TQFB high speed FPGA. All right, so FPGA, so that's probably the glue. That's probably some of our glue logic. All right, let's get the rest of this pulled apart. Let's carefully take this backboard off. These screws go straight into plastic, so that's not good. based on our serial number right here, Q28602, I think we are 602 because the 28 was the Cobalt number, wasn't it? Or was it 27? I forget. I doubt we're the 28,000th Qube 2. I just don't see it. All right. It's a fairly basic. We got just a little plastic button membrane. Standard 16:2 LCD. I don't think the backlight pins are soldered. We'll take a closer look at this later on. Let's try and get the rest of this out. And we are out, except for the dodgy, loud, and not required fan. Well, I say that. The fan is probably there for the hard drive. You don't need the hard drive, then you don't need the fan. Okay, standard IDE cable. What do we got down here? We have... We've got the standard... It is dusty. We've got the VIA VT82C586 chipset. That's given us our IDE and other stuff. We've got an Intel 21143. And a second Intel 21143. That's strange. Let's give this thing a dust down so we can see it better. So we've got our optics or our magnetics for our two Ethernets. I'm wondering if these are our Ethernets connector driver chips. I thought we were using Tulip chips, but I'm guessing not. Let's look this up. 21143PD. That might, well, they don't say Tulip, and they don't say DEC. 21143PD. Let's take a look and see what data sheet we get. Intel controllers, Ethernet controller chip for Intel. Okay. Huh. I thought we were rolling with Tulip Ethernet drivers, but like, your Ethernet chips are as big as your IDE controller. That's crazy. That's, considering we've got like 10 pins coming in on the Ethernet, and we have literally 144 pins on each controller. That's wild. We do have a coin cell. Let's test that coin cell. 2.98, that's still valid. That's wild. I'm assuming it's a CR2032. XBT1, all right. Swiss. It doesn't want to spin. Do I have any of those? What do we have? 2032s, 2032s. Apparently we have a whole bunch of 2032s. Does it look the same size? I think it does. All right, let's test one of these. Let's get that one measured and see if it is. I don't like having old batteries in there. 3.31. The question then becomes, what is being saved in the CMOS? And can I do that with it powered down? Is that even a thing? So I think based on this information, grain of salt, it's only storing the date and time. And then it tells you it's soldered to the motherboard, which it's not, because we can see that it's in a socket. So, well, that's a note for the rack. Let's take another look. Okay, so this guy ripped his battery straight off the main board, trying to lift the pin. So how is this soldered? You are not through hole. You are surface mount. Oh, I just noticed the not PCI slot is facing in a different direction from the spare PCI slot. Interesting. Okay, let's see if we can pop this sucker out. What's our spring tension like? Renata, Swiss made, no date. Energizer. There we go. New battery. We need to get this guy desoldered, and then we're going to replace him with a barrel jack that we're going to screw onto the back of the case, which, let's test that theory before we go any further. So we want to get this guy. Okay, so he does fall through. So we get a washer on one side. Now the question is, can we get it locked down on the other side with enough clearance? And it looks like we've got plenty of clearance from the Ethernet jack. So this is the second one. So we're looking good. That's good. All right, let's figure out what traces are ground. All right, continuity mode. All right, we've got 3 holes. Okay, so we're going to desolder this. We have our 2 inputs, ground and positive. That's all we need to wire up. This pin is wired to the chassis and nowhere else on the board. So originally I was really worried about wiring in a 2-pin power supply, and I've done a ton of Googling on the power supplies. I mean, the Chinese power supplies are crazy. They'll sell you a shielded one that has a 2-pin AC prong. Like, that's not connected to earth. So I've done a whole bunch of continuity checking. I've gone over the connectors. There is no connection of the shield to anywhere else on this board. It is not connected to the screws, which means it's not connected to the chassis. Now, it is connected to the chassis through the DB9. That's the only connection to chassis that is really tied to. So I don't think we have a problem. Famous last words. At worst, we can tie a 1 megohm resistor between DC ground and the chassis, but I'm not going to do that. I just can't find a proper power supply that has a 3-pin with it shielded properly. So it's such a pain in the butt. There is one on Amazon that ships from China, but the pictures are so sketchy that I can't trust what I'm getting. They don't show you the picture of the barrel. One picture has a 3-pin AC prong, another picture has a 2-pin AC prong. So I can't guarantee what I'm getting, which really sucks. And they all use the same photos. So we are just going to go for it. So let's get this desoldered. All right, we're back. And we have got our power connector removed. Now we're going to attach a detachable connector so we can get it in and out of the case with ease. I'm going to use the mounting holes as strain relief. So we're going to come in, go under, and come back out so we can get a close-up. So we're going to go under and then back up and solder on. So let's get our wires stripped. I don't want any frayed ends since we're going to go through a couple holes. Looks good. Good enough for me. Strain relief. No whiskers. Let's run a continuity test. No continuity. Very nice. But we don't need 6 feet of wire inside the case. But I think let's wire this up to the DC power supply and test everything outputs the way we want. Got too many cables. You get out of here. Okay. Let's get the DC power supply. Strip this back a bit more. We're going to cut this off later anyway. Red to red. Yep. All right, DC power supply. So this is how it came. So we know this works. All right, if this works, we should get the basic output. We need to be able to turn it on. So we need our little LCD display. And I want something else to keep that off the metal chassis. All right, let's try that again. Okay, nothing's touching. We've got 1 amp and maybe we need more than 1 amp. There we go. He booted up, and it is booting the inbuilt firmware. So we are still good. 64 meg of RAM, yep. RTC fail. Interesting. We changed the battery. Set RTC to correct date. Okay, because it thinks it's midnight. All right, so that's good. So let's get it all back into the chassis and see. We got to get this guy in, which means this guy. We can cut both of these down because this just needs to exist with enough to attach to this guy. Okay, so let's cut these two down. And then I've got to find some, I don't know where my Kapton tape went, so we'll have to find some shrink, heat shrink. How far down do I want to do this? Say we join that there. Good enough. Red to red, black to black. This would be, you know what? Okay, that'll fit through the hole. I was like, are we going to get that through the hole in the chassis? But yes, I think we will. All right, so we've got the screw, and where is... actually, you know what? You know what? Oh, nope, we got it. It does fit. All right. Let's start reassembling. Well, first, let's see if we can ditch this noisy fan. All right, one noisy little fan out of the way. Sunon KD1204 PKB3 DC 12 volt 0.6 watts. Let's check out our replacement fan. I don't really think we need to move any airflow, especially knowing that we are not having a hard drive in here. So we have the good NFA 420 40mm by 20mm. So it's not as big. We also need to convert it down to a 2-pin. I would kind of like the 2-pin connector. And a little bit of airflow is always good. So I guess we do want the Omni connector. This honking huge cable though, I don't want to have to repin. We're going to have quite a bit of cabling just for the fan. I'm not the biggest fan of these Omni connectors. We're going to need 2. As far as I know, with the Omni connector, you just strip the wire and shove it in. We should probably check that. Ooh, no stripping needed. Okay, it's one of these, it cuts it away for you. I don't like that. Omni join, okay. 6 foot of wire. All right, let's get you into the case. Making sure we check the airflow. All right, we're in. We are in. Trimming will be later. All right, let's get you in the hole. The nut doesn't want to go over. It's that micro. Oh, damn it. The nut is like 0.01 of a millimeter because of the threads to fit over the housing of the thing, the plastic. Damn it, we were so close. The idea is perfect. Taking the easy way out. We're in. We are in. And I've got the distinct impression we've just grounded the chassis. I have the distinct impression we just grounded it. This will either work or go up in smoke. All right. You're the wrong kind of screw I want. Let's get this bottom screw in. All right. Let's get the top corner screw in. And then we will check our power supply, which you can't see on screen. We will check our blue lead power supply. That will turn off if we have a short. Yay for a nice inbuilt power supply short detection. All right, you guys are all in. I'm going to put one of these guys on the RS-232 port just to lock that in. I don't want to do it too tight. There we go. All right. Everyone, please be watching the blue light. We do not have a short. Let's get the rest of this screwed back in. Red to red. All right, that's all hooked up. Let's do another. All right, still no short. So let's use our original sticker RAM. Well, first let's get you on board. Let's test our original sticker RAM. We should get everything the same. Such a tight squeeze. All right. So in theory, when we hook up our null modem cable and our power supply, and our blue light is still on. Blue light is still on. Ooh, fan is rolling and it's booting up. Okay, we had the power switch on. Let's get our thing on the screen and let's see what we get. There we go. Everything's good. Let's get memory and everything else installed. So we've got to get our drive in, our SATA converter, and our RAM. First things first, let's get the RAM going, one thing at a time. Ye old 64 meg stick is out. Let's hope this, what do we got here? 128 meg EDO. So in theory, we should now have 256 meg. Of RAM. Let's see. Let's bring our window back. Four 64 meg banks. Very nice. Okay. Next step. Okay. And I need to get at least one screw in up the top here. So let's see, where'd our drive screws go? There's our drive screw. For giggles, let's make sure it lights up. We have green light. I do this in reverse so I can see where I'm putting everything. All right. Let's give this box a clean. And all we have left over, I believe, we have one screw and 3 drive screws. So I think we're good. Let's give it a simple green wipe down. Oh yeah, look at that Cobalt logo. One Qube refit. Cobalt Qube. Can we get a better shot? Cobalt Qube. All right. I don't necessarily need to trim these, but I think we will. Just a little bit. Done. All right. Hardware is done. The next part of this project is going to be us staring at a terminal screen, working out how to do a network restore. I will catch you in the next video.